Mitch.
You took the coordinates for 2 points and plug them into the equation.
Okay, so tell me what to write.
Y minus.
No, I'm not doing that one. I'm doing this method, using this one.
Okay. And y equals negative 4/3 x plus y.
So, right. So what would we don't have B yet. Using this format only, how do you find B? Remember from Algebra 1, Marissa? Plug in 0 for what? Well, to find the y-intercept, you would typically plug in a 0 of x. But that's if you already know what the equation is for the function. If you're just looking for the y-intercept, you make x 0. Here, if we make x 0, we're going to get y equals b. So it doesn't really tell us anything. Since we don't have anything to plug in for b, because that's what we're trying to find, we should have something to plug in for x and y. Yes?
Can't you plug in a coordinate?
You plug in a coordinate, negative 3 for x and 6 for y. So these 3's would cancel, the negative would cancel, so it would be 6 equals 4 plus b. You would subtract 4 from both sides and you would get 2 equals b. So your equation would be y equals negative 4/3 x plus 2. Do you remember doing it that way? That's usually the way Algebra 1 teachers initially teach it. Because they're usually fresh off the concept of any XY pair that works is a point on your line. So you're thinking that X and Y is a point on your line. And so if you know a point on your line, you plug it in for X and Y and you find B. So that's usually why I think conceptually we start with that way, because, and not only that, but you're fresh off of graphing from Y equals MX plus B form. And really that's the only format Algebra 1 teachers start with. Usually we don't start by throwing all these formats at you. We let you master this one first. Frankly, because it's just really easy to say slope, y-intercept, plot those things, and you can graph your line most accurately that way. In reality, though, point-slope form is the easiest method for... We got a nasty little fly around here. Andrew, do something about it. If you got that with your pencil, I would have been very impressed. A magazine, your binder next time might be the better route. But I appreciate the effort because that would have been wildly impressive. So point-slope form is really much easier to write an equation because you plug in the slope, you plug in the point, and you are done. Okay? Here, you plug in the slope, you plug in the point, you have to calculate B, and then you have to back up and rewrite. So, for this particular one, since we already calculated the slope, we would just plug in for the slope negative 4/3, and you can choose either XY coordinate pair. I'll choose 3, negative 2. So that'll be y plus 2, right? The double negative will change that to look like a positive 2, even though the coordinate was negative 2. Are we good with that? Equals the m and then x minus 3. So even though that looks like a negative 3, the negative belongs to the format of the equation and the 3 is actually the coordinate. And you're done, like I just said. That is the equation of a line. Now, if they specifically request it in slope-intercept form, then we just distribute. So that would be y plus 2 equals negative 4/3 x plus 4, and then we subtract over the 2, and you see how it would roll into the slope-intercept version. Okie doke. So those are the two formats that we use to write an equation. And you can go with whatever is easier for you. How many people think they'll use point slope to write equations of lines? How many people think they'll use this method? Oh, a couple of you. This really should be the easier one. This one will take you much less time, especially because you don't have to distribute and solve for y, usually, okay? Does anyone know the third format of a line that's popular that you would never write the equation of a line using it, but you might have to transfer your slope-intercept into it? Does anyone know what standard form looks like? You are going to know once I tell you, but does anybody recognize that? Okay, standard format is actually the format that a line is most often in when you're doing like elimination. So it's like an ax plus by equals c, where a, b, and c are whole numbers. So your x and y terms on the left. So, for example, if I were to try to get this one in that format, I'd have to add the 4/3 x over. So it would be 4/3 x plus y equals 2. But if you didn't hear me, I'm going to say it again. A, b, and c have to be integers, or integers. I said whole numbers, which is actually wrong. They have to be integers. So they can obviously be negative. So I'm going to have to do what to both sides to make each of these coefficients integers? Because right now 4/3 is in my way. I have to clear fractions, right? Just like we cleared complex fractions the other day. You find the least common denominator, which is 3, and you multiply both sides by that. On your left-hand side, be a little bit more careful because you have to multiply both terms by that, but that'll give you 4x plus 3y equals 6. And there is now the third format of this same line. Slope-intercept, point slope, standard. Any questions on that? In the next exercise, it just wants you to sketch the function or the two-dimensional graph. This one's written in function notation. What does that line look like? F of x equals 3. Joe? Yes, y equals 3 basically. And he's kind of drawing it in the middle of the air, so I know that he knows what he's talking about. Horizontal would have been a good descriptive word. It's just a horizontal line through 3. That's just y equals 3. So in B, if you just saw that equation, you might think, well, they must be asking me to solve it. They're not. They're asking you to graph it. However, in order to graph it, I do recommend that you solve it, subtracting 12 from both sides and dividing by 3. They're not looking for a solution. They're looking for a graph of this. And what does a graph of this look like, Bailey?
A vertical line, negative 4.
Perfect. Okay? Marissa, this is going to hit on what you mentioned earlier. Okay, finding the intercepts. When you already have the function in front of you, and actually let me back up. This particular line right now as it sits is not in standard form, it's not in point slope, and it's not in slope intercept. Just an FYI. I don't know if this particular format has a name. It might, where everything's over on the left and it equals 0. If it has a name for the type of format it is, I don't know what it is. I'd have to Google it. But I will tell you that, not necessarily this chapter, but throughout the year there are moments where you'll check your answer in the back of the book and it will be written in this format where it all equals 0. I haven't been able to track down a good reason for it. I don't know if I've asked Mr. or Mrs. Hill yet, but I'll see if I can remember to ask them. You keep asking me so that I can remember to ask them. But you will see that, just an FYI. Anyway, determining the intercepts. X-intercept, right? If you're going to cross the x-axis, you're going to have a y-coordinate of 0. Every point on this line has a y-coordinate of 0, whether it's 1, 0, 2, 0, 3, 0. So if you're looking for where it crosses the x-axis, you set y equal to 0. That'll cancel that. You'll get 6x equals negative 15, and x is going to equal negative 15, 6. And 6 goes into 15 2 times with 3 out of the 6 left over, so that's 2.5. So negative 2.5. That's where the x-intercept would be. The y-intercept, think about anything on the y-axis, has an x-coordinate of 0, whether it's 0, 1, 0, 2, 0, 3. All y-axis points have an x-coordinate of 0. So 6 times 0. And then solve. Negative 3y will equal negative 15, and y will equal 5. One mistake that people do make, and then I think they like kind of lose their way because they're like, how did I end up here? Is sometimes people will calculate the x-intercept, calculate the y-intercept, and they'll just plot the point negative 2.5, comma 5, which is somewhere over here. And that point's not on your line, by the way, right? This x-coordinate, remember, was calculated with a y of 0, and this y-coordinate was calculated with an x of 0, and those are your 2 points that you connect to make the line, if you're going to graph by intercepts. Any questions? The next exercise asks you to find the slope of a line passing through 2 points. Obviously, the points are not numerical points, so it makes it a little bit tricky. I want you to take a minute to apply the slope formula, which, again, just in case, y2 minus y1 over x2 minus x1. But I know you did a lot of average rate of change last year, so I'm not at all worried about whether or not you remember that. All right. Nate, what did you get? Say it one more time.
Negative 2c over a minus. No, I got negative 2c minus.
Oh, up top. Over B. Sorry. Anybody get anything different? Bailey, what'd you get?
A over B.
Anybody get anything different? Raise your hand if you got A over B. Raise your hand if you got negative 2c minus A over B. So, Nate, send me your paper. take a peek. Without looking, raise your hand if you think you can tell me what, Nate. I don't really know because I haven't done it yet, but I'm assuming, Nate, because you were outnumbered, that it was wrong, but maybe not. Raise your hand if you can guess what you think Nate might have done wrong, even before I'm going to show it to you. Connor. So, did you do this minus that? And you think he did this one minus that one? It doesn't matter, by the way. Whether you do y2 minus y1, I could just as easily change this equation to y1 minus y2 over x1 minus x2. Did you know that? Who's to say what's 0.1 and what's 0.2? Right? If I flip the order of these and just list one first, it doesn't matter. What you can't do that sometimes happens is y2 minus y1 and then start with x1 minus x2. That's a problem. That would be a problem. Who has another guess? Go ahead.
Maybe you distribute the minus in subtraction.
Right. That's my guess as well, because when you subtract like x2 minus x1, you need to distribute. So let's see. Take a minute. We'll play teacher. We were all wrong. Nate, pick a number between 1 and 17. Bailey. This is an active day for you.
Yeah.
Do you know what he did?
It looks like he distributed a negative like backwards into the first.
Perfect. Yep, that's exactly it. Nate, this isn't a plus c times negative 1. You treated it as if that negative was like out in front. If it is out in front, then it's negative the parentheses. Since it's after the fact, it's just a plus c minus c, which should just be a. And then you would have landed where our second group did, which was a over b. Follow? Okay, so he actually did remember to distribute. I'm sure there are people out there that did not speak up that forgot to distribute, so make sure you do that when you're subtracting binomials. Anything else on that one? And then lastly, just find the value of y that would make this true. So essentially, we know what the slope is supposed to be. We're missing a coordinate. So y2, negative 4, minus y1, y, over x2, 4, minus x1, negative 2, equals 1/3. And how do we solve something like this? Aiden, what would you do? Okay.
Then you would multiply both sides by 6 to get the negative 4 minus 1.
Okay, so he's multiplying both sides by 6, so we'd get negative 4 minus y equals 2. 6 times a third, right? A third of 6 is 2. And then from here, pretty straightforward. This actually was not what I was looking for. I was thinking cross multiply, but that's fine, just as well. Add 4 to both sides, negative y equals 6, and then y equals negative 6. Easy enough? Okay. So your homework, you're going to have a lot of time to probably finish it, maybe even. One person is going to finish her test after school, and then you will get your test back tomorrow. Okie doke.